Hello, Dr. Corso. My name is Benjamin Brodwolf, and this will be the video that will be showing the final project for natural language processing. So for my project, I did a analysis of intercepted messages and trying to identify code words within those messages to benefit the police in trying to understand these encoded messages and trying to catch the criminals at hand. So what's the problem statement? So the police need to identify potential code words. The ultimate goal is to be able to find the next place or the strategies of the criminals and be able to predict what's going to happen next. So the secondary goal in this program that I made is going to reduce noise in the textual data, and it's trying to automate the pre-processing, making it a much faster way of doing it rather than just going and reading all of the data that the police have. I just want to say that in this particular use case, we are going to be using websites that talk about the subject. However, in the real world, if you had some sort of giant data set of a captured cell phone or documents that were found by the police, they would be using that instead. So secondary goal 2 would be able to create a opportunity for a human to review this data, making sure that nothing is lost and nothing is looked over. So in my approach, the key steps were tokenization, which is one of the main subscribers to this plan. So the first step in any textual analysis in general is to break it down into tokens, which are the smallest units of meaning typically in words. And it's basically the foundation of the analysis because it allows me to treat the data set as a collection of individual elements that can be further processed. So using this function here, one of the first things that we're going to do is load the tokens from this function here that we're going to import from the NLP library. So next, after using nltk.word tokenize and splitting it into tokens, we're going to then move on to step 2, stop word removal, and this is going to reduce noise. So natural language processing includes many words that are essential for a grammar, but they don't carry much semantic weight in analysis, like the, or and is, and these are called stop words. And by removing them with the NLTK's corpus, that reduces the noise, and that allows the system to focus more on the meaningful content at hand. So this is really critical in finding the significant tokens rather than just finding the cluttered text that is a result of just the stop words. And then on to step 3, lemmatization. It's for the precision of the semantic data set. So one of the most important steps is applying lemmatization to reduce words basically in their root forms to reduce them to their root forms. So running, imagine you have the word running, then or runner, it would become run. And this is making sure that all these words are treated as one. And this process is the key to simplifying the analysis. And it's also going to make sure that the accuracy of the tokens and the token counts is better. And then we're going to do custom filtering. This is important because this depends on your data set and what you're trying to accomplish with it. So for the police's task at hand, they're trying to find code words used by the cartels. So the police can actually just pardon basically words that they are not going to think as suspicious. And this allows the computer to not do it and someone to do it quickly and to then get down to the suspicious words that could definitely be part of some plan that they're using. So then frequency analysis is just going to be the core of the system. Basically, it's the ability to highlight the potential code words by counting the occurrences of each token. And high frequency candidates could and should encourage further basically investigation of it. So then at the end we have a bar graph that we are going to see. So onto the code, we can see that I have nothing in these files here because we start out with nothing in these text files, just to show you that the code works. So then we have all of these URLs that I have researched, but this would be some sort of URL to or a PDF that it's scraping through, maybe a full download of a cell phone's messages archive or something like that. So first we run this, and if there's any that I can't find the text on or it's not working, it'll send an error, but it will continue through the array basically of the URLs, and you can see that it finished there. So it successfully scraped through the ones that it could. It failed on, it looks like 5 of them, so it really only did like this many of them. But now in our articles.txt we can see that we should have a whole bunch of text in here. So did it work is the question. Let's see, why didn't it work? It should work. Okay, I'm not sure why it didn't work. I'm going to save this maybe, and then I'm going to run it again. Okay, for some reason that time it worked after I saved the blank document. I think it had a whole bunch of stuff in it before maybe. So that means I should probably save this one too, and those. So now I have all this data here that I can scrape through. So this would be just the full archive of the chats or something. So now in this file, we run this one. And this is going to break that data down into tokens. And then it's going to find the semantic precision by lemmatization, and it's going to reduce the words down to their root forms. Then it's going to custom filter. So now it's prompted the user. So I would be at work here trying to find our cartel members. And so would you like any of these words to go in commonwords.txt? So these are really, really common words, and it would take a long time to get down into the words that are not used this many times. But we can say, yes, I would take some of those out. I can take use, drug, Spanish, one, get, and Mexican. So now all these words are going to be added to my common words. And I'm going to be prompted with more words that it's asking me if I need to take out. And you can see that the lemmatization is working well, and none of these are ing or usage or something like that. But this is going to take forever. So let's say no and get our first bar graph. And these are the most common words that could be code words. It's also put in this file here. This is going to show us our possible code words. This is going to show the words that have been omitted because of how common they are. This one is the custom common omission, that it's not extremely sure that it should be omitted. And then that's our data. So let's go ahead and go to our data set here, which has a lot of commonly used words. And that will be good to go put in our common words. So after we put that in there, we can run our function again. And this would be thousands of words that probably should not be counted, and just be using the suspicious words that it's looking for. There's a lot of words in the English language. So it's left us with this. So we can go ahead and take some of those out again. Actually, go is probably good. They're probably going somewhere. Something is good. I don't know. Many, another, take. These are all just English words that should be out of there. So now we're getting down much lower numbers. And if we keep doing this over and over and we have a much larger common words data set, it does take longer to run, but then we're going to find the most commonly used code words that the police can be suspicious of. So I'm going to explain what this code does line by line. So the code actually just begins by importing essential libraries like NLTK, OS, matplot, library, Python plot. So these are being used for the text processing and like the visualization tasks. NLTK, which is the natural language toolkit, helps with the tokenization, the lemmatization, and the stock word handling, like we were talking about earlier. While the visualization is the matplotlib.python plot, and that's created for used for creating the bar graphs, which is really cool that it can just create that using a Python imported library. Now, next we have downloading the resources. So nltk.download is a function that is used to download necessary resources like Punkt, Stockwords, and WordNet. So these resources are really helpful for tokenization and filtering and stuff like that. Then we have initialization. So this is a set of English stock words that is loaded into the nltk.corpus.stockwords. That's going to filter out the frequently used but non-informative words like the and. Then WordNet lemmattizer is basically just being initialized to simplify words to their root forms. Then we're going to define the load common words function. This is just going to check in the file common words and that's really helpful because this is what's going to have the customizable part of our project here that is going to be stripping each word and convert it to lowercase, and then it's going to be both noun and verbs that are going to be added to the common word set, which is really helpful that we can now easily filter out words that are not helpful for us to find the code words. Then we're going to define the preprocess function. This is going to convert the input text to lowercase and tokenizes it into like the individual words using word underscore tokenize. And then this is where it is going to make sure it's a noun or a verb, and then it's going to return the processed information. So defining the interactive prompt function is just going to display the 20 most common filtered words, which is what I chose to just keep things simple. Just a good 20 most common words that we can just see in the terminal there, and we can respond to the code and just be able to see the next data set and the next one and the next one, so that it can be easily interacted with, and it's going to be much faster than just reading through the data set. Basically impossible to do that. And then we're going to be defining the plot bar graph, which is going to just give that some variables there, just to build the bar graph, make it look all nice. So that's what's going to be using the matplotlib.pyplot function, and that's going to just include the x-axis and y-axis and just make it nice looking. And in our main right here, this is an important part that's going to be the script, basically, that is going to be initializing the repeat variable to true for looping, and it's going to load the common words using the load common words function, and it's going to print the count of the loaded words. And it's just got some emojis in there just to make it look nice. And then we have splitting the filtered and omitted words, which is going to be the words in stop words or common words, and they're categorized as omitted because they're just going to be filtered out and separate the objects, or counter objects are created for filtered and omitted word counts. I think that explains my project pretty well. Thank you, Dr. Corso, for listening, and I will see you in class.